This week we'll be talking about the tools that a programming environment like MATLAB gives us to help create useful programs. These tools include the many built-in functions that MATLAB supplies. We've learned about a few of these already, but now we're going to cover many more of them. We'll see how we can print on the screen in a nicely formatted manner and how we can create graphical output. And perhaps most importantly, we'll see how MATLAB can help us track down and eliminate the errors that inevitably creep into our programs. Before we look at new tools, let's revisit one we've used already, the square root function. Suppose I want to take the square root of 9. Well, we know what that is. 3, no surprise there. But let me show you something that perhaps is surprising. I'm giving square root a matrix. So I'm going to ask you to take the square root of matrix. What does it do here? Well, the matrix I gave it was a 3 by 2 matrix, 1, 4, 9, 16, 25, 36. I specified it right here in the input argument. And what square root does is go to each one of these elements, take the square root, and put it at the corresponding position in an output matrix that's the same size as the input matrix. So we got square root of 1 is 1, square root of 4 is 2, 9 goes to 3, square root of 16 is 4, 25, square root of 5. So this is an example of something that's not supported by all programming languages. It's polymorphism. If the type of an input argument to a function can vary from one call of the function to another, it's called a polymorphic function. Polymorphic means having multiple forms, and polymorphism is a powerful feature because it allows one function to handle a huge variety of inputs, which can save us a huge amount of work because we avoid having to write a huge variety of functions. Furthermore, as we'll see, not only can the type of the input arguments vary, but the number of arguments can vary as well. And we can make the function's behavior change when the type or number of arguments changes. Many built-in functions in MATLAB employ the first form of polymorphism by returning an output that's shaped like its input. For example, as we've seen, if we call the square root function with a 3 by 4 matrix, it'll return a 3 by 4 matrix. If we call it with a 1 by 2 matrix, it'll return a 1 by 2 matrix, and so forth. This shape-shifting of the output to match the input is in fact the predominant form of polymorphism in MATLAB, and it's very convenient. But not every built-in function behaves that way. And we're going to look at one right now that doesn't. The function sum doesn't behave this way. Let's make a vector v. Let's put some elements in it. Doesn't make a difference what it is. And let's give this vector to sum. There, I guess that's right. 1, 2, 3, 4, yeah. It sums up the elements of the vector. Now let's give it a matrix. Let's make the matrix A equal to 1, 2 on the first row, 3, 4 on the second one. So there's A. Let's give it sum A. When you give a matrix to sum, it returns a row vector, and each element of it is the sum of one column of the matrix. So 1 plus 3 is 4. 2 plus 4 is 6. However, when you give it a vector, like we did up here, it's vector v, it returns a scalar that's equal to the sum of the elements of the vector. So sum is polymorphic, but the output that it returns doesn't have the same shape as its input. We've seen how to make a function return more than one argument. Well, some built-in MATLAB functions do that. The maximum function, for example. Here we gave max a 4-element row vector, and it returned the maximum number in that vector, the element that's equal to 8. Now let's ask max to give us 2 outputs and see what happens. I'll give it the same input. This time it gave us an 8 and a 4. The 8 is still the maximum number. The 4 is the index of the maximum number. So the fourth element here was where the maximum was, so it returns a 4. Note that returning 2 output arguments is not the same as returning 1 output argument that is a vector with 2 elements. Size does that. S is a vector. It has 2 elements, 3 and 2. This is a 3 by 2 matrix, so it returned that vector 3, 2. And when I say it's a vector, just to establish that, here's the first element. There's the second element. The function max wouldn't allow us to catch both outputs as a single vector, but size does. However, the function size makes it possible also to save the elements of its output in another way, like this. This time it put the number of rows in the first output argument, and it put the number of columns in the second output argument. So, size behaves differently depending on the number of output arguments we ask for. This is another example of polymorphism. Polymorphism based on the number of outputs requested by the caller of the function. Note that if you want to write a function that has these polymorphic properties, the ones that depend on the number of output arguments, you have to write it that way. It's not something MATLAB does for you. We'll see later how you do this.